Good morning, everyone. In the previous class, we have learned how to set the right angles using different instruments in chain surveying. In this class, we are going to learn cross-staff survey. Cross-staff is an instrument which is used to set the right angles, and we can do survey along with this instrument, which is called cross-staff survey. The object of cross-staff survey is to locate the boundaries of a field and to determine their areas. Here we have to locate the boundaries and we are going to find the areas. The instruments used in cross-staff survey are two chains, arrows, ranging rods, cross-staff, plumb bob. In two chains, one chain is used for measuring the baseline and the other is for measuring the offsets. Cross-staff is used to set out the perpendicular directions of offsets which are more than 15 meters. If the offset distance is less than 15 meters, then we can set the offset by eye judgment. For accurate work of setting offsets, we can use optical square. As we have already discussed about optical square, we can use optical square if we require more accuracy. Let us discuss the general principles which we will use in cross-staff survey. Measurement by chain and cross-staff is based on two formulas. The first one is the area of right angle triangle is equal to the base of triangle multiplied by half of the perpendicular, where base represents the distance along the chain which we laid. Perpendicular represents the offset distance. So the area of right angle triangle is nothing but half into base into height. Using this formula, we will measure the area. And another formula is the area of trapezoidal is equal to the base multiplied by half of the sum of perpendiculars. If we have two offsets and a base on main chain line, we can directly calculate the area of trapezoid, which is equal to half into a plus b by a plus b into h, where h is the distance on baseline, a plus b are offsets, a and b are offsets. These are the two general principles which we will use in measuring the area by cross-staff. Now we'll discuss how the cross-staff survey is being conducted in lab in field. So let us discuss method of cross-staff survey. In this diagram, we can observe that a boundary A, B, C, D, E, F is there, and we are going to find out the area of the boundary. Here in this diagram, we can observe a chain is laid between points A and D. Because these 2 points are very distant from any other 2 points. So we have to select 2 points such that the distance between the 2 points is the maximum compared to any other 2 points in a given field. So here in this diagram, A and D are far away. So we select these 2 points to lay the chain line. A chain is laid in between A and D, where we can observe a dotted line which represents chain. And offsets are measured along the chain line. We have 4 offsets which are taken at G, H, I, J. These 4 points are on the baseline. The offset distances are GB, IC, HF, and EJ are calculated using chain or tape. So here the entire boundary is divided into 6 parts. The area of the entire boundary is calculated by adding all the areas of individual parts. The first one is a triangle, and second is a trapezoid, third is a triangle, fourth, sixth also triangle, and fifth is a trapezoid. Here we are going to find out individual areas and we are going to add to get the total area of the boundary. The offsets to the boundaries on either side of it are fairly equal. The offsets are taken as they occur in the order of their chain edges. The first offset is taken at a distance at a point Z, second is at H, third is at I, and fourth is at Z. To check the accuracy of the field work, the chain edges of points of intersection of the chain line and the boundary should be noted. After the fieldwork is over, the survey is plotted to a suitable scale on a paper. Now the figure is divided into number of triangles and trapezoids depending upon the number of offsets which we have calculated in the field. The areas are computed by the formulas which we have already discussed, the area of triangle and area of trapezoid. Now that if we want to calculate the total area is sum of all the individual areas in the diagram. We'll solve one of the problem related to cost of survey so that we'll be having better understanding. Plot the following cost of survey of a field A, B, C, D, E, F, G, H and calculate its area. Here we need to understand the diagram and we have to plot the diagram. Then we have to divide it into number of triangles and a trapezoid. Then we have to calculate the areas individually. After that, adding all the areas will get the area. 0 represents the starting point of the survey. These numbers 100, 180, 300, 490, etc. These represents chain edges on a main chain line. Chain edge means the distance from the starting point of the survey. So we have different chain edges 100, 180, 300, 490, 650 and 750. Offsets are taken at a distance of 180 on either side. And if we observe, another offset is there at 300, 490, 650. So first we will draw the diagram, then we will calculate the individual areas to get the final answer. So this diagram shows a rough diagram of the given problem. This is not to scale. We will draw a table for calculating the individual areas. Here in the diagram we will have 7 individual areas 1, 2, 3, 4, 5, 6, 7, out of which 3 are trapeziums, remaining 4 are triangles. We'll calculate the area of these diagrams individually. So we'll prepare a table. We have 7 diagrams, 4 triangles and 3 trapeziums. We have figures A, J, G, JG in front, MF, EP, PED, ABK, BKNC and CND. The chain edges for this starting at 0, ending at 100. Means the base is 100. In the same way, we have to calculate the bases for all the diagrams. Here we have list of bases for all the diagrams. So these are the offset distances given. So here we have to take the mean values. These are the mean values for offset distances. Based on this, we can calculate the area by using formula of PH for triangle and A plus B by 2 into H for trapezium. All the areas are calculated. To get the final answer, we have to add all the areas. The total value is 2,14,000 square meters. In this way, we have to solve for calculating the entire area. The area in terms of square meters is 2,14,000. If you want to convert into hectares, we have to divide it by 10,000. We will get 21.4 hectares. We'll solve another problem afterwards, and we'll go to another concept, which is called triangulation. Based on this, the area of the area to be surveyed is divided into network of triangles and rectangles. The principle of chain survey is triangulation. Triangulation means dividing the given area into number of interconnected triangles and rectangles. All the triangles should be well conditioned. This is the condition. The sides of various triangles are measured directly in the field. Now angular measurements are taken. It is the simplest kind of surveying, and the triangles are plotted from measured length of sides. Let us see the procedure for smaller areas. The sides are measured in the field and the offsets are taken to locate the details. The plan of the area and the details are plotted in the office from the linear measurements which are taken in the field. Here, figure 1 shows the rough diagram how we will take measurements. For larger areas, the system consists of framework of triangles. The exact arrangement will depend upon the extent of area to be surveyed. Generally, a long baseline is run through the middle of the area. This baseline is used for locating details by forming the framework of triangles. Check lines are used to check the accuracy of framework, and tie lines are used to collect the interior details of our data which are not accessible from the baseline. So in this figure, there are two check lines drawn to check the accuracy of the work. This is the entire boundary. These are some of the offsets which we have to take. This complicated diagram shows the network of main chain line which is run from A to C. These are tie stations T2, S1, S2. Here the dotted line from A to C represents the baseline, and these are the lines which represents the tie lines. Some of the lines are drawn in between to check the accuracy of the work, which are called check lines. This is how we construct the entire diagram, the structure, entire system of lines in a given field. According to the principle of chain survey, the area is to be divided into number of well-conditioned triangles. What is meant by a well-conditioned triangle? According to the principle, an equilateral triangle is an ideal triangle. The triangle is said to be well-conditioned when no angle in the triangle is less than 30 degrees and more than 120 degrees. Here is the example which shows a well-conditioned triangle. The three angles are 50, 60, 70, which are not less than 30 degrees and which neither more than 180 degrees. Therefore, it represents a well-conditioned triangle. Well-conditioned triangle are preferred because their apex points are very sharp. They are located by single dot. There is no possibility of relative displacement of plotted point. We have ill-conditioned triangle also. A triangle is said to be ill-conditioned when the angle is less than 30 degrees or more than 120 degrees. Any angle less than 30 degrees or more than 120 degrees represents an ill-conditioned triangle. Ill-conditioned triangles are not preferred because their apex points are not sharp and well-defined. There is a possibility of error in the plotting. So these are the reasons why we does not consider ill-conditioned triangles. The most important part in chain survey is recording the measurements, which is done in field book. So the measurements recorded in field book. We will discuss in detail about field book. The book in which survey is recorded by measurements and sketches is called field book. It is a long book of size 20 centimeter into 12 centimeter and opening lengthwise. Unlike our traditional book, it has an opening in lengthwise. There are two forms of field books: a single line field book, double line field book. In the single line field book, a single red line is ruled down in the middle of each page and represents a survey or chain line. The center line represents main line or survey line. The distances are written along the line while the offsets are written opposite them to the right or left according to their position, whether they are left or right. Along the chain we have to write the distances from the starting point. This is convenient for large scale and much detailed dimensional work. And we have double line field book. It is similar to single line field book, but instead of single red line, two blue lines about 1.25 centimeter, 1.5 centimeter apart are ruled at center. In this column, chain edges are entered. So in double line field book acts as a column in which we will enter the chain edges of different points. The space on either side of the column is utilized for drawing, sketches, writing offsets and notes located from the chain line. For ordinary type of work, this double line field book is used commonly. And we will learn how the recording is done in the field book. The pages of the book are blank and machine numbered from 1 to 100. The recording is started at the bottom of the page and work upwards as if we are writing them on actual chain line. The name and number of survey line, survey station and symbol of starting and ending of each line is clearly entered in the field book. So this represents a rough diagram, how the field book looks. We will start entering the readings from bottom to top, just like a chain. So this is the starting point and this is the last point. So these are all the offsets which are on the right side and these are all the offsets which are on the left side. The numbers written here represents the chain edges of different offsets. The field book entry is something very similar to this diagram. The initial and closing chain edges should be enclosed in the symbol delta. So it represents initial and final chain edges. Tie or subsidiary station should be indicated by a circle or oval round at their chain edges. All the distances along the chain line are entered in the central column and offsets are written opposite to them. As work proceeds, the details of offsets are sketched with conventional signs. It is not good to crowd the details. It is better to write the details clearly. A good field book record is one which can be understood even by a person who has not visited the site. So it should be very clear so that it should be understandable for everyone. When someone visits the site, he has to understand the details of the field by looking at the field book. That is how we have to record the details. We have some of the important points to be considered in booking the field book. Each line should be recorded on a separate page. All measurements are recorded as soon as they are taken. We cannot uh, note down the recordings after 2 or 3 measurements. We have to record as early as soon as they are taken. The recorder should always face the direction of chaining while booking the field notes. The note should be complete. Nothing should be left to the memory, because if we keep some readings in memory, we will remain forget and we will end up with some errors. So therefore, whenever we take the reading, we have to enter it immediately. And at the same time, we should not leave any space in between the pages. They should be clear, neat, and accurate. Figuring should be neat and writing legible. There should be no overwriting of the figures. We may come across so many uh, books where overwriting is done. In most of the cases, overwriting is not accepted. Therefore, there should not be any overwriting. If something has to be changed, then we have to draw a round circle over that reading, and we have to write it on the top. Again, we have to do the signature at that place. Explanatory notes and references to the pages where necessary should be added. In some cases, some extra explanatory note should be added to understand the particular detail. Therefore, we have to add that extra notes required whenever it is required. Entry should be recorded with pencil. The book should be kept clean. No entry should be erased. If any entry is wrong, a line should be drawn through it and a correct one is written above it. If an entire page is to be discarded, it should be crossed and marked as cancelled. A reference to the other page on which the correct notes are written should be made on. Sketches of the various features located should be neat and lucid. The sketches need not to be scale. They may be drawn without a scale. Separate page should be run for each tie line, if any. The complete record of the survey should include the following points. These are the things which we have to remember while recording the field book. Initially, it has some title of the survey, which is written on the top of the field book, and general sketch of the area which we have already surveyed, and location sketch of the main and tie stations. Record of the chain lines, the date of the survey in which we have conducted, the names of the members who are involved in the survey, that also has to be incorporated in the field book. The page index of chain lines and stations are to be mentioned for better understanding of the field work. In the field, we may come across different objects. We cannot represent the same symbol for every object. Therefore, we have some conventional signs for which we generally come across. Most of the times, this is very essential to draw a north direction. So this symbol represents a north direction, which is a circle denoted by an arrow. We have main stations, which we have already discussed, which is denoted by a triangle. And if we have any tie stations, these tie stations or intermediate stations are to be represented by a circle or oval shape. The chain line is indicated by a intermediate dotted line, a straight line, and the three dots. And a straight line and three dots. This is how the chain line is represented. Similarly, for all general objects, we have different symbols which we have to use in drawing the field book. So this is the symbol for a wall or a wall with gate. We have level crossing. This shows the level crossing where railway line and bus route coincides, intersects. So these are some of the basic symbols which we will use for normal objects. This is a Pakka building. This is a Kacha building. Similarly, we have different symbols for different objects which are useful in the chain circle. So for representing different temples, church, mosque, we have different symbols. And these are the different symbols we will use in chain circle. Electric line, electric point, etc. These are rough pastures, barren lands. This is how we will represent in field. Now we will move on to errors in chaining. We have different types of errors in chain survey. They are systematic errors, accidental errors, and mistakes. Let us see what are systematic errors. These are the errors that will have some magnitude and direction under similar conditions. These may be positive or negative accordingly. The measured distance may be too large or too small. These errors can also be called instrumental errors. We cannot avoid these type of errors, but these are cumulative and these are going to be added whenever we survey. Survey, we use the chain for number of times. These are cumulative in nature and very serious if we ignore, because for every chain length, these errors will go on adding and ending up with a big error. So we have to consider these errors before calculating the final results. So again, systematic errors can be classified into two types: positive errors and negative errors. Positive errors. The errors make the measured length more than the actual length. So the correction will be negative. Positive error means the actual length is measured more than the actual value. So this is a positive error, which is more than the actual value. Here we have to apply some correction, which is negative in nature. If the length of the chain is too short, it means it measures long distances. It measures it measures too long. So for example, if the true length of the line is 90 meter, if we use the chain 30 meter, we get 3 chains length. If the chain is too short, we will get more than 3 chains. Means the error is positive. Here we have to apply negative correction. And we have different reasons for the short length of chains. Bending of links, removal of too many links in adjustment of length, knots, lower temperatures which may cause the chain to contract, and finally end up with shortening of the chain. chaining along the slope due to sag. These are all the reasons for shortening of the length. And we have negative errors. These errors make the measured length less than the actual length. The correction is positive. The length of the chain or tape is greater than the standard length. The true length of the line measured is too short. For example, if you measure a distance of 90 meters with a chain more than its standard length, you will get a lesser value than the actual length. In this case, we have to add some value to get the correct length. So the correction is positive here. The reasons for the greater length is wear and tear of the instrument, at the same time flattening of the rings, which causes increase in length of standard chain. Opening in ring joints may increase in length of chain. Higher temperatures may cause expansion of the chain, which means the length of the chain is increased. In these cases, we will get uh, negative errors. The correction here is positive. We have already discussed the correction for true distance. It is incorrect length of chain divided by correct length of chain into measured length. We have solved some of the problems also in the previous class. And we have compensating errors. These are not too much dangerous because they are compensating in nature. These are errors arises due to imperfect human eyesight, improper manipulation of the instrument. These may be positive or negative, are likely to be compensated finally. So we no need to worry more about this type of errors because at the end tend to compensate on their own. Sometimes they may be positive and sometimes they are negative. For example, the pull applied to a chain is sometimes more and sometimes less than the standard pull. So in such cases, they will compensate on their own. And finally, we have mistakes. Mistakes generally occur if proper care is not taken while measuring and booking the readings. This can be avoided by taking proper precautions and care, and by applying suitable checks during the measurements, we can avoid different mistakes. The common mistakes which we generally come across in the field are displacement of arrows, which represents a wrong length of the chain. If the arrow is displaced from one point to another point, the distance we measured may come erroneous. Failure to observe the zero of the tape. Some people start uh, from the very starting point of the tape, and some people start at the joint from the tape, which is not correct. So wrong counting of arrows. Some of the people may count arrows wrongly, which results in mistake. Reading from wrong direction of the chain, which results wrong erroneous results. Reading numbers incorrectly, reading wrong metric marks, wrong booking. These are the common mistakes we will come across. So in this class, we have learned different principles being used in chain survey and method of doing cross-staff survey in the field, and how we will measure areas of different fields using cross-staff. At the same time, we have learned different mistakes that are possible in chain survey, and we have learned the reasons why these mistakes are happening and how to minimize these mistakes and errors. So in the next class, we will discuss the remaining topics. For today's class, we will close the session. Thanks for listening. Thank you.